I want to look at some examples of finding areas of regular polygons. You may know a formula for finding the areas of regular polygons. The formula is not 100% necessary, but it does work. Our geometry book says that the formula is half the apothem, and the apothem goes from the center of a shape to the midpoint of a side. Our book says that the area of a regular polygon is half the apothem times the perimeter. Okay? I think the Springboard book says that the area is the perimeter times the apothem divided by 2. Okay, it's all the same thing. Half the apothem times the perimeter, perimeter times apothem divided by 2. Again, I don't care what version of the formula you use. I also don't care if you don't use the formula. If you just want to break the shape up into triangles and you want to do it that way, that will also work, okay? And that's what I'm going to take a look at here. So let's say I had a regular hexagon. And let's say that the side lengths of that hexagon are 10. All right? If I break this thing up, I can break it up into 6 triangles. Okay? And so if I can find the area of one of these triangles, I'm going to be able to multiply that by 6 and find the area of the whole thing. All right? This is where angle measure is going to come into play. You need to know the angle measures of the shape to be able to get the information that you need about the triangles. Okay, so let's talk about a hexagon for a second. A hexagon has 120-degree angles. And what that tells me is, if this angle here is bisected, that means I've got a 60-degree angle there, a 60-degree angle there. This angle up here is going to have to be a 60. Hexagons break up into 6 equilateral triangles, okay? And be very careful because not all polygons break up in equilateral triangles. You're going to think they do looking at a picture, but just hexagons break up in equilateral triangles. So, if you know the equilateral triangle area formula, you can crank it out really, really quickly. If you remember, you can take a side squared divided by 4 times radical 3, and that'll give you the area of one equilateral triangle. So in this particular case, a side length is 10. You can square it, divide by 4, multiply by radical 3. That's going to be 100 divided by 4, which is 25 radical 3. Okay, there are 6 equilateral triangles as you go around here. So if you multiply 25 radical 3 by 6, you get 150 radical 3 square units, and you're done. Okay, great way to do this. All right. If you don't know that formula, of course, you could just break the triangles up into 30, 60, 90 triangles. You've got a 60 there, you've got a 30. This half side is going to be 5. This is going to be 5 radical 3. Okay, so the area of the triangle is going to be half the base. And make sure you're using the entire base. You don't want to divide by 2 twice. It's half the base times the height. That's going to be 25 radical 3. Okay, and then you have 6 equilateral triangles. 6 times 25 radical 3 is also going to be equal to 150 radical 3. Amazing, you get the same answer. All right, or you can use the formula. Okay, and the formula comes from finding the areas of triangles. If you proved this last year, you may have shown it with different triangles and kind of worked out the formula from that. Again, I'm not going to redo that now, but that's where it come from. So in this particular case, the perimeter would be 6 times 10, right? Because you've got, so that would be 60. The apothem here, you do have to know that this little 30, 60, 90 triangle, that would be 5. The apothem would be the height of one of those triangles. That's why that is important enough to have a term. The apothem there is going to be 5 radical 3, and then you're dividing by 2. Okay? And so it's 1/2 the apothem times the perimeter. And if you work this out again, you're going to get 300 radical 3 on top. Half of that is 150 radical 3. So 3 different great ways to find the area of a hexagon. Probably the most basic regular polygon, other than a square or an equilateral triangle, that you're going to be finding the area of. Okay? Now, let's take a step farther. If you work with anything that's not a hexagon, it's not going to break up in equilateral triangles. And this is where trig is going to come in handy, and probably where the formula is going to come in handy a little bit more. All right? So let's take a look at a pentagon. Regular pentagon. And let's say it's a regular pentagon. Let's say that the side lengths are 8. Okay? Angle measures are hugely important. Okay? Remember, pentagons have exterior angles that add up to 360. You can divide by 5, and that tells you that each exterior angle is 72 degrees, which is going to mean that the interior angles are 108 degrees. Okay? Notice, 108, not 120 like a hexagon. These triangles are not equilateral triangles. So if you break the shape up into triangles, this is a 108 degree angle that's going to get split up. That's a 54 degree angle right there, not a 60. Okay, these are not 30, 60, 90 triangles. So be careful about that. Okay, only works for hexagons. Okay, so anyway, to find the length of the apothem, the perimeter is going to be real easy here. If we're taking, the perimeter times the apothem divided by 2, perimeter is going to be 5 times 8, which is 40. But the apothem, we're going to have to do some work for it. Okay, let's look at one of these triangles individually. So that's 4, that's going to be 4. Okay, we've got a 54 degree angle here. The apothem is over here. Okay, that apothem is what we're trying to find. All right, you're going to need a calculator. All right, this is not a special triangle. We're going to have to set up a little trig equation here. Notice we've got a tangent relationship. Okay, that's a tangent of 54 is equal to a over 4. And you can multiply both sides by 4. A is going to be 4 times the tangent of 54. That's going to be our apothem length. Okay, so 4 times the tangent of 54. You're going to put that in. It's about 5.5055, something like that. Okay, multiply that by 40, and then divide by 2. And we're going to get an area that's approximately, looks like it's going to be about 110.11 square units. Okay? Something like that. All right? Now, the other approach here, could just find the area of one of these triangles. Okay? The area of one of the triangles is going to be half the base of 8 times the apothem, which is the height of the triangle, which is about 5.055. Okay? And the area of one of those triangles would be about 22. Then you can take that answer and you can multiply by 5, and you end up getting the same answer here. So again, you don't need that perimeter times apothem divided by 2 formula. You can just find the area of one triangle and then just multiply it by 5, and that'll work out the same way. Okay, let's try one more here. Let's try an octagon. They're pretty common. All right, let's say we have an octagon. And we'll go back to 10 unit sides here on the octagon. Okay, you need the angle measures for an octagon. Okay, you really should memorize the angle measures of an octagon. But if I were to give you something like a dodecagon or that kind of thing, you're going to need to make the calculation by hand. So just as a reminder, for an octagon, you can divide 360 by 8. It tells you that the exterior angles are 45, which means the interior angles are 135s. So we've got a 135 degree angle here that's getting bisected. Okay, half of 135 is 67.5. So again, not an equilateral triangle. It's not far off, but it's not equilateral. Okay, so this length here is going to be 5, and we're trying to find the apothem. And notice once again, we've got an opposite side and an adjacent. So it's going to end up being a tangent relationship here. We're going to have a tangent of 67.5 is equal to 8 over 5. Okay, when you solve, you're going to be taking 5 times the tangent of 67.5. And that's about 12.071, we'll say. Okay, so we can find the area of just one triangle. That's half the base of 10 times the height of about 12.071. That's going to be about 60.355. This is an octagon, so there are 8 of those. We can multiply that by 8, and we get approximately 482.843 square units. Okay. Again, if you want to do half the perimeter times the apothem, that also would work. The perimeter, we have 8 sides, 10 units each. The The apothem is about 12.071. We're going to divide by 2. And you should get the same thing. I'll try it, make sure it actually works. Hey, look at that, we get 482.843. So again, I don't care how you find the areas as far as the different approaches. If you want to find the area of one triangle and multiply it by the number of triangles, that's great. If you want to use the perimeter times the apothem divided by 2, that's great, okay? But just make sure you know how to find the angle measures of regular polygons, because if you can't do that, you're not going to be able to use trig when you need to use it to find the length of the apothem. So hopefully that helps with some of these problems.